Non-road mobile machinery is any combustion engine-powered machine or vehicle that is not solely intended for carrying passengers or goods on the road. This includes machinery and equipment used on construction sites and in quarries, and agricultural applications, as well as handheld equipment such as chainsaws. In Europe, all NRMM types have been categorized under Stage 5, and this includes a general catch-all category for compression ignition engines with power ratings of between 56 and 560 kilowatts. Gas and particle emissions from the combustion engines installed on non-road mobile machinery contribute to air pollution, and in Europe, the EU is committed to phasing out equipment with the most polluting engines. Similar initiatives are rolling out elsewhere in the world. Pollutants include carbon monoxide, carbon dioxide, and nitrogen oxides, as well as hydrocarbons from unburnt fuel and engine oils. In the future, particle numbers and particulate matter, the latter of which is already included in US legislations, may also be considered NRMM emissions under EU ruling. Emissions are reduced through more advanced engine technologies and control methods, as well as increasingly sophisticated exhaust gas after-treatment systems, the development, testing and certification of which is performed in engine dynamometer cells. Effective from the 1st of January 2017, the European Commission introduced the NRMM regulation, which includes the in-service monitoring of those non-road mobile machines with engine power ratings in the 56 to 560 kilowatt range, a range that is likely to widen in the future. This monitoring is to counter observed discrepancies between engine under test emissions in the laboratory and real-world emissions, or RWEs, when the engine is installed in equipment and in use. Some machines, like handheld chainsaws, do not currently require in-service monitoring. Instead, operational life emissions tests are performed in an engine test cell. In-service conformity, as opposed to monitoring, is already part of the type approval process for heavy-duty vehicles under real-world emissions and for light-duty vehicles under real driving emissions. For both, portable emissions measurement systems, or PEMS for short, are used. HORIBA's onboard emissions measurement system is the OBS1. Installation of a PEMS on or in a light or heavy-duty vehicle is relatively simple. For some non-road mobile machinery types, the PEMS can operate alongside the equipment as it is operated under real-world conditions. In other cases, the PEMS will need to be mounted on the machinery. Here, it will be exposed to high vibration and shock levels, dust, temperature extremes, and the elements. While it is normally the responsibility of the manufacturer of the engine or the machinery under test to protect their PEMS in such harsh environments, HORIBA has developed a rugged enclosure for its OBS1. The enclosure has springs to protect against shock and vibration in all three axes, fans for cooling purposes, and filters to remove dust. It also has weatherproof entry points for cables, and D-ring lifting eyes and access for forklifts for installation purposes. Developments such as these are enabling the capture of non-road mobile machinery real-world emissions data. This data can then be used on and by engine testbeds to simulate realistic loading conditions. Moreover, the accuracy of that real-world data will become increasingly important as a so-called conformity factor, which allows for discrepancies between real-world and test cell established emissions, is likely to be reduced in the future. The quality of data established in the test cell is important too. Here, products like HORIBA's pitot tube flow meters come into their own. They measure, but do not disrupt, the gas flow. and high-frequency sampling means exhaust pulsations are not missed, which could otherwise produce misleading results under some conditions. Pitot tube flow meters, or PTFMs, are ideally suited to the high-temperature exhaust gases produced by NRMM engines under load. And a recently announced dual-tube version can measure exhaust flow rates over a much wider dynamic range than a single-tube design, whilst maintaining a low exhaust back pressure. Accurate and real-time gas flow rates can also be established for many non-road mobile machinery engines using ultrasonic methods, as employed by HORIBA's EXFM1. This unit can be used in conjunction with a host of other instruments, such as an air-to-fuel ratio analyzer. The new regulations, and others on the near horizon, are changing the way engines and engine-powered vehicles, machinery and equipment are being developed. As an OEM, your products must meet current legislations, and as a commercial enterprise, you want your products to satisfy market demands in terms of power, torque, endurance and reliability, and to go to market quickly with competitively priced products. Only accurate, trustworthy emissions data, recorded in the field and in the lab, can help you meet your compliancy obligations and your engineering and commercial goals. With decades of experience in developing core technologies, products and complete solutions in emissions measurement, and being at the forefront of current compliancy requirements and future regulations, HORIBA is well placed to help guide you with your unique project requirements through the complexity and fast-changing regulatory testing landscape. And with our comprehensive test cell and PEMS solutions, we can help you find that trustworthy data in the lab and in the harshest of real-world operating environments.